Fair enough. Cool. Well, I thought we might try meeting notes. I don't know if that is a useful thing, but I figured it might end up being pretty useful when things like this happen and like Sagi can't come. Just to have like a written record that he could skim through in 5 minutes and see, what we talked about. So if someone is willing to take notes, that'd be awesome. Because I find it hard to like speak and keep track of the cameras and take notes.
Yeah, no, all I'm going for difficult.
Okay, that would be awesome.
Mike, yeah. You're the only one with a computer here.
Just create like a Google document and just type whatever.
Like we have the meeting, like we integrated a Google Doc already.
What did she?
Just have like not a perfect minute, but just yeah. Like,
where is that?
Oh, if you open your Slack, there is a link for that.
Yeah, so on there, I've got 3 items at this point. So talking just a little bit about the plan for the discretized docs. Then I'm hoping to get some input from Dom on the upgrades for the potential fields. And then maybe just go over like if there's pull requests that need motion on them. Is there anything else that we should add to this?
Not really on my end, I have to be honest. No.
No? Okay. Cool. Well, let's then start with the docs, if that works for everyone.
Yeah, sure.
Okay. I'm just going to share my screen. And what I'm actually going to do is go to the Verde docs, because this is what I've been following in concept for our docs. I'll just post this link in the notes. So excellent, you already got it. So first thing to notice, I think, is like the subheadings that are on the outline here. So getting started, the user guide, and then the reference documentation. So what we have currently is we sort of have like the user guide and reference documentation all muddled together. So like the API is sort of documented in some of the usage, which I think is just confusing and hard for people. So I think that's one of the first things to note. There's some really nice, I really like how he's done the user guide. And so if you look at these are actually basically generated by like the Sphinx gallery. And so these are Python files that have then been compiled to like RST and rendered as such. So they've got the code snippets, output, and then explanation of what's going on. So we've got that in addition to having a gallery or like an example gallery that's just more of an overview of like what are some of the things that the package can do. And then the other thing that I like is actually then the way he's referenced the API. It's just a high-level grid or like a high-level set of summaries that describes what each module contains. So if you go to verde.datasets.checkerboard, we can then see like what the docs for that are. He's done some stuff that I think would be nice to get in there, but we're perhaps a little ways out, and that's okay. I really like the way that he also includes which examples use that function. So like that kind of thing would be nice to get, but I think as a first pass, if we can get the summary, a bit of a user guide, and the getting started in place, I think would be in much better shape. So does anybody have, first of all, before I move on, does anybody have questions about that or want to look into the code at all?
Yeah, so Verde, like everything that's on the left, right, Lindsay, is all the functions that that are in the package. But I guess we would have a lot more. We have many more modules in SimPEG, so we'd be expanding each.
Well, so expanding, so that's the reference documentation that you're talking about, right?
No, above this, you know, he has like, these guys, yeah. So he only has a few of them, right? He only has a few functions.
Yeah, so we might, like for SimPEG, we'll probably need to break this down into like by method. So inverting mag data, or mag probably forward and inverse, for each of the different like styles of inversion. Same thing for EM and all of that. Yeah. Yeah. So we might have like sort of two levels here.
So you would put application rather than classes.
Yeah. I think for the user guide, we need to like try and get in the head of somebody who's like, I want to invert time domain EM data. How do I do that?
Right.
They don't actually care what the classes are, right?
Totally.
And then here in the reference documentation, that's then where we actually document the classes. Does that make sense?
Yeah, totally.
Okay. So what I've been playing around with for the discretized docs is something similar. So having a getting started, most of this content was stuff that was already there. Doing a user guide. So I think like having same style where we just show like, here's a tensor mesh, here's how to build it, here's what the origin is, those kinds of things. Having same thing for cylindrical, like having one for each mesh type. So having curvilinear mesh, octree, all of that. Having a bit of an overview of finite volume. This I think we could expand to like the tutorial that, the leading edge tutorial that we wrote ages ago. And then this one actually just needs to be translated from RST into a little Python script so that instead of these being like the matplotlib includes, it's all just a Python script that can then be downloaded as a notebook, and used as a tutorial. And then here, the API reference. This is sort of same idea. I've started with the meshes and then going into numerical operators, some of the IO visualization, and all of that. As I'm doing this, we're trying to move more so towards NumPy styled docs rather than the Sphinx styled. So here they've got, you know, the general documentation. You can have an example, notes, attributes. And what's nice, so this is then an attribute or a property, basically, same thing. It has a type, it has a description, and this is like exactly what is pulled up if you do the question mark in the Jupyter notebook, which is like so much friendlier than looking at the colon, like the double colon param da 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 da, which is in the current standard Sphinx like documentation style. So I'll try and get some of the documentation ported over to this, but I will need help from other people to get all of it. And we'll just sort of try, with all future documentation, to go with this style. Does that work with everybody? Do you think that's makes sense? Is that something you'd support?
Yeah, just give us an example and then we will help out.
Okay.
Yeah.
Cool. Yeah. So I'll get like maybe one module, maybe like the tensor mesh or something like that, totally cleaned up, and then we can go from there. Yeah. And then once this is done, then doing the SimPEG docs, I think will be timely, because the SimPEG docs are just a bit bigger and like it's easier to flesh stuff out in discretize first, I think. Cool. Any questions around that? Thoughts? Ideas?
It's long overdue.
Fair enough. Yeah, I mean, because I think too that'll end up helping, especially in SimPEG, with how many questions we're getting, is if we can actually point people to like well-documented examples. That should really lower the load that we have to, you know, describe in emails. Cool. Dom, do you want to take the take the reins and talk a bit about the potential fields?
Well, I started Thibaut suggested to just update the notes on the pull request. So I just added like 3 or 4 bullets. I forgot what you wanted me to do. You wanted me to highlight code and write down.
Yeah, if there's just any like you know how you can actually review your own code. So you know how like you can look at the code diff. I'll pull this up. I'll just share my screen. So here, if you look at pull requests, and then this guy.
Yes.
If you then go in and look at files changed, if you wouldn't mind just updating, especially in the optimization, or just like add a couple comments about where order or things changed. So like here, for example, like P was previously. That makes sense? Just because well, maybe I'll share just why this is a tricky diff to sort through.
No, I understand. I mean, is it really like? Do any of you really care to know like the details why each line has changed? I mean,
it doesn't need to be each line, but like what is hard right now is I can't tell what's an important change versus what is not. And so like because the optimization is such a core part of the package, just trying to understand like where are the important changes, like what should I think about, I guess. I was having trouble just comparing these two things. Does that make sense?
Yeah, it's just I don't know. I don't know if it's worth the time, you know, because I can spend like an hour on this, but at the end of the day, it's inverting. All our examples are passing. It's change of variables, and I don't know, you know, it's CG, so.
Okay, I guess like so it's either you know, like half an hour on your end, or it's also, I mean, because this is a core part of the code, I want to get my head wrapped around what's changed. So I can spend some more time and like just try and send you specific questions. I realize it is just CG, but
it's CG minus. I took out the SciPy part if there was no bounds, because we're solving things differently. If there were bounds or not, that's really all it is, you know.
Okay, fair enough. Because that's
the solver ICG is not ours, someone else. So we're solving things slightly differently every time. So I took it out.
Okay, can you just like make a comment of like where?
Yeah, this guy, you see all bounds active, it was going to solver ICG, and otherwise.
Okay.
So I took that guy out, and then
that can go also in the release note. That's
okay. Thanks, Dom. Yeah, it's just because like sort of trying to get my head wrapped around like what changed. It just sort of looked like everything changed. And so if this is the main thing, then like that's totally fine. That's all I needed to get my head around. Okay. Cool. Yeah. Any other things you wanted to highlight with this, or?
Well, no, the big ones is that we're increasing the coverage a lot, because instead of having the different, like, you know, MVI, amplitude, and stability in separate classes, I bring them all in together. So that reduced the amount of the number of lines by a big number.
Okay, nice.
And I did the test. I did test an example, right, for the MVI and the amplitude, and just a ton of Pepe.
Cool.
Naming, yeah, that's pretty much it.
Nice. Sounds good. Cool. The other thing I was hoping to request is if somebody wouldn't mind reviewing the pull request I have linked there. It's for the DC fields derivs.
Oh, yes, right.
I think. I'm not entirely sure why Travis. I'm just gonna have a quick look. Oh, it looks like one of the ones just kind of randomly errored. I'll restart that and we'll see if that's all okay. Yeah, so if somebody's willing to take a look at that, that'd be helpful. It implements getting electric fields and currents from DC fields objects, which we didn't have before, or data. Sorry, we had the ability to get it in the fields, but we couldn't get electric field data. So now we can. Cool. All right. Yeah, so what else are people working on? Where do we need more support or like things to be moving in SimPEG?
Personally, I'm still working with Dask, right? Trying to like optimize all the way to the combo function.
Okay.
Because currently I can parallelize the tiles, but when we do the forward models, it loops through all the problems one after the other.
Yeah.
So that would be kind of like the highest level that we would like to parallelize, I think.
Yeah, I had a really good chat with Matt Rocklin, who develops Dask, and just getting an overview of like Dask delayed and how that works when we have like multiple things that need to be delayed, and you can safely pass Dask delayed like functions or computations as arguments to other Dask delayed things. So what that means is that if you have like used Dask.delayed in the potential fields code and you're able to parallelize the forward simulation, then we can still at the higher level parallelize over multiple objective functions, and that's fine. Dask can safely compute the graph to do that.
Yeah, that's right. That's good.
Yeah.
And does it matter if parts, because obviously we're not going to Dask everything right away, right? Let's say we delay the forwards on the combo objective function. I guess it doesn't matter, right? You will parallelize that part, but not the sub levels.
It should be okay. I think it's smart enough to recognize like that the decorator doesn't matter in that case. Are you using decorators or are you wrapping functions? How are you doing that?
I'm using as much as possible the Dask operators, so like the sum and the power and all that, right? So they're delay functions.
Right.
Delay functions.
But like in the code, are you using the decorator on like functions, or how are you implementing Dask.delayed?
I'm using all functions that say like Dask sum is a delayed function, right? It only calculates the sum until you ask to compute. So I change the code instead of decorators. I'm using as all Dask operators. Okay,
cool. Yeah, no, I think that totally makes sense. Yeah, so if you like want to chat one-on-one about getting it into the objective function, like I think we can actually do that pretty quickly. Yeah, because that'd be super helpful to have. The other thing, I was chatting with Sagi over the weekend just a bit about the simulation class and try and revive that and get that going again pretty quickly. Because I think that will actually simplify a lot of the parallelization. And also, I mean, because we need all the classes to serialize for the more complicated codes in order to be able to do that. So, yeah. Oh, yeah. And then I got another email from, her name's Jennifer. She is in Italy, and she's been using SimPEG or playing around with SimPEG for EM inversions. And she asked if we would help put together a tutorial. So I'm going to start working on a notebook, and then we'll send it around for feedback and ideas and things like that of how to best explain what's going on in the time domain code. And then we're going to walk through some of that code with her at the end of the month on a conference call. And so we can try and loop in whoever's interested and willing to help out. So if any of you guys are interested, just, yeah, stay in touch on that.
Are you communicating with us through personal email, or is that like through, I haven't seen that in the issues, etc.
Right now it's through email. Yeah.
Okay.
Yeah. Yeah, but we can try and move that to issues maybe once we've got a small like example notebook up and running.
Lindsay, I remember when you're finished, when you're near the end of your research, you were serializing your inversions, right? You had JSON files to control your inputs. Did I forget this?
No, that's like, I was serializing. Yeah, well, I was serializing basically everything and then writing, like automating the writing of a Python script.
Oh, okay.
But then I'd saved, like, what are you wanting to serialize?
Yes, because like, you know, I'm working with like different people on different branches, and now I have like way too many scripts, and it's taking me forever to maintain all the inversion scripts.
Yeah.
It would be nice if we could just have, version, if I at least personally, if I could version control scripts, inversion scripts, we have all the defaults, and then we have a JSON file that just overwrites the defaults on demand. You know, that would be much easier to maintain.
Yeah. Yeah, okay. So that will take, there's a few things that need to get done. We need to take another look at the directives and be careful about, because one of the things that I've noticed in some of them is in a lot of cases we're like randomly attaching properties to the directive. And we need to be careful about that because that can cause confusion. And like, in some ways that's what happened with the confusion, or it's not the same thing, but it's analogous to what happened to the confusion where we had the survey and the data misfit each having their own standard deviation that were not tied to each other. And so we need to be careful that inversion directives don't like make copies of properties, but that they're always referencing whatever they should be. And then we need to be able to then, yeah, serialize the inversion directives, and then we should be able to serialize the inversion object. Is there one example? What is one directive you would like to start with?
We can talk about it offline. Yeah, I'll come up with something. It's
okay.
Just I thought you had done this already for your research, but I guess not.
I have done something like very close to this and have ideas about how we should do this. I just never got to do it like fully in SimPEG. But if you have like 3 inversion directives that you're always using, then we should be able to get this going reasonably quickly.
Well, I was thinking also more like bigger, right? Optimization, inverse problem, all these pieces that we're basically virtually always using the default. But we have to recreate scripts every time to put it together.
Yeah, yeah.
Kind of like a top level.
Yeah, but I mean, in order to do top level, we have to be able to serialize all of the individual objects. Yeah. And so, like, I think the directives are a reasonably clean place to start. Is because it should be pretty clear, like, what the exact parameters that the directive needs to know in order to recreate itself. Then same thing, like, we'll repeat the pattern for optimization, all of that sort of stuff. Yeah.
Okay, got it.
Yeah. Okay.
Yeah, we can talk about that later. I'm gonna encounter the same issue, but very soon.
It's because also when we want to hook up GeoFuels to SimPEG, or the other way around, if we don't have to maintain a script, if we can just send like a bunch of parameters and SimPEG knows how to deal with those parameters, we're just going to save ourselves a lot of trouble, right?
Yeah, yeah. Okay, this is a really good point of, yeah, we need to be able to serialize everything. And that's not something that it can currently do. Do you have, what is the file in GIF tools where you're sort of like doing the translation between?
It's a Python script.
Yeah, could you just like offline afterwards Slack me the link to that? And because that would actually just be helpful to see what you're doing right now. And then that can also help us prioritize which objects we perhaps start with.
Yeah, copy me in that message too.
Yeah, works.
That sounds good. Cool. Okay. Yeah. Anything else you guys want to go over today?
Nope.
I'm good.
All right. Perfect. Sounds good.
Have a good
Well, see you guys later.
Thanks, Lindsay.